Okay, so my name is Mike Conway, and I used to work in Nigel Collier's lab at the National Institute of Informatics in Japan on the Biocaster text mining system. But nowadays, I work in Wendy Chapman's clinical text processing group at UCSD. Okay, so Japan has some fairly serious public health challenges, a history of terrorist attacks, lots of long-term worries about bird flu and SARS, and also it's a centre for natural disasters. We all know about the recent, well, last year, the earthquake in Japan and the subsequent tsunami and the Fukushima Daiichi disaster. Okay. Okay. So Biocaster is a text mining system for news text. What it essentially does is it takes unstructured news text and it applies it through a semantic pipeline which outputs structured records. And these records can then be used to populate databases, to create alerts, or to populate a geolocating map, like Google Maps or something. And at the core of the Biocaster system is text mining. That's a core technology behind it. And text mining is typically, it's a combination of natural language processing, machine learning, ontologies, and reasoning. Okay, but one of the key difficulties, one of the key research challenges with text mining is ambiguity. Ambiguity is endemic in natural language. It's very hard to escape from. In all text mining tasks, we're faced with difficulties of ambiguity. And here are some examples. So, Obama fever builds as Black Americans await a new era. Right, Obama fever, probably not the kind of fever that we're interested in from a public health perspective. Okay, similarly, Vista attacked by 13-year-old virus. Again, computer viruses aren't really our focus here. And bird flu outbreak drill spooks Manitoba town. Okay, well, a bird flu outbreak drill isn't a bird flu outbreak, so we need to discount that. Okay, so the Biocaster project, which is based at the National Institute of Informatics in Tokyo, it has a publicly accessible web interface, which you could go and play with, and also email alerting that you have to sign up for. Okay, the project began in 2006, and it initially targeted Pacific Rim languages, but it's shifted slightly now to also cover non-Pacific Rim languages like Farsi and Russian and things like that. And we have quite a few regional partners in Japan and in Thailand and Vietnam. And we're trying to extend that to China and to Laos and other countries. Okay. Okay, so the actual workflows. We start off with unstructured news text, and then we clean that text. We get rid of all the HTML and the advertising and everything. And then we use machine translation if we have to. And then topic classification. Now, topic classification identifies if it's a disease-oriented text or not. Okay. And then we do named entity recognition. Now, named entity recognition identifies the salient concepts of the text, so the disease names and the locational names. And if you've got that, you're in a pretty good position to start populating an alert or a Google map. Okay, so I'll just describe this system to you. So we start off with some event in biological reality, like the cholera outbreak in Iraq in 2007. Now that's reflected in the grey literature. The grey literature are things like blogs, news text, that kind of stuff. So we point our NLP algorithms at this literature and extract an event, assign that event a certain alert level. Okay. It's important to, well, it's probably important to mention that oftentimes news stories precede pro-ed mail. Although there's some evidence for that. It's not entirely clear, but there is a bit of evidence to support that view. And finally, I just want to mention the DDD system, which is a Twitter-based system which uses some of the Biocaster modules. And that's an experimental system at the moment, and it's based on monitoring disease outbreaks in cities. Okay, so that's me done, so thank you very much.